Hello. Today we'll be going over lesson 4 of 4th grade, which is algebra. Find the value of each expression. I'm going to attempt question number 1, 4, and 9, which seem to be good indicators of how to solve the rest of the questions. So number 1, 5 plus 2 plus 6. Pretty straightforward. You can add all the way through here. 5 plus 2, which is 7, plus 6, which is 13. You can just take it one term at a time and jump to the next, however you feel comfortable. Now let's try something more complicated, like number 4. We first notice these parentheses, which, if you look at it in terms of PEMDAS, or the order of operations, you always want to solve what's in the parentheses first. So 9 plus 4 here is 13, and then after that you can go from left to right, addition and subtraction. So this is 20 minus 13 plus 3, go from left to right. 20 minus 13 will be 7, 7 plus 3 equals 10, and this will be your answer. And one more, let's try 9 here with bigger numbers. Same principles apply. Start with the parentheses. 201 minus 202. I do not need to write that out again, but if you were to do this, this will give you 99. And from there, you can just go left to right. 120 plus 99, which should give you a result of 219. Alright, moving on. Choose the correct value for each variable in each equation. Now, what they mean by variable here is some sort of letter like G, K, most commonly X. And these letters represent an unknown value. And so instead of the number, we get a letter that just stands in for what that number might be. So this is the concept of algebra, where you need to use certain rules to be able to figure out what that unknown number is to make the equation possible. So taking a look at number 1, 9 plus some number, which we don't know, is equal to 12 plus 30. So let's just simplify this on the right side here, which is 42, right? Because 12 plus 30 is 42. And now this means 9 plus some number will equal 42. And now the way you can solve this is you can think about it like getting rid of 9 on both sides to leave G alone here so that we can figure out what G is equal to. An easier way to think about it also is, since 9 plus something will give you 42, that must also mean that 42 minus that 9 will give you something, because it's like working backwards. So let's try that. Let's subtract 9 from both sides. And this will leave you with G is equal to 33, because 42 minus 9 is 33. Let's try one more, because this is rather complicated. Let's try 3. 92 plus X is equal to 193. Again, here, we need to figure out what this number here is. We don't know what it is. And thus, what you can think of it as is getting rid of this 92 from both sides. We'll leave the X alone here, and we'll show what X is equal to. So if 92 here minus 92 is 0, right? So it's just X on the left. And then on the right side, if you do 193 minus 92, you will end up with 101. So you can say that X is equal to 101, and this will be the unknown value that you have found. Next, solve and identify which property you used: commutative, associative, and identitive. To review what these properties are, these are all properties of addition, and commutative means you can add in any order. Associative means any grouping you can add. And identitive means anything you add by 0 will just be that number. So number plus 0 equals number. We'll write it like that. So let's give it a shot. I will do everything in this left row. Now number 1, something plus 32 is equal to 32. Now we notice that these two numbers are exactly the same, and remember what we said about the identitive property? A number plus 0 is just going to be that same number. So we can imagine that these are the two numbers that are the same, and we're just adding 0 here. So the property here is identitive. I'll just write it like this, and answer 0. Number 2, 7 plus 4 is equal to something plus 7. Already we notice that we have one similar number here, and the only difference is that the place that they're being added, right? So as soon as you see a slight change in order in the addition, you would immediately think commutative. So that just means that these numbers were flip-flopped, So it would be 4 plus 7, and they will still both be equal, the same thing. So this will be the commutative property. I'll just write it this short form. Now for 3, we already see parentheses. Anytime I see some form of grouping, I am already thinking associative, because this rule states that in whatever grouping that you add, it will still be the same. So here, again, 4 plus 9 is grouped, plus 5 is equal to 4 plus some number and 5, grouped again. But remember, these groupings do not change the result. So we can use exactly the same numbers in whatever order and in whatever grouping. So the only number not from this left side included here is 9, so we'll just fill that in, and this will be the associative property. I'll write it in the short form. And 4, we see a 0. As soon as you see a 0, you immediately think back to identitive. So 0 plus a number will equal that number, and 80 is that number. So we will put that in here and say this is identitive. Alright, now onto our favorite part, word problems. John has captured 9 chess pieces. Carol has captured 4 chess pieces and taken 3 more. Carol acts it out and decides to capture 5 more pieces to have the same number as John. Describe her error and write the correct answer. This type of question tests if you can correctly see what is being done wrong here and correct that mistake. So Carol already starts with 4 captured and captures 3 more, or takes 3 more. So that means now she's up to a total of 7 captured pieces. And now we can compare that to John's amount, which is 9. So if you compare 7 and 9, all you need is 2 more pieces from 7 in order to get yourself to John's amount, which was 9. However, Carol unfortunately believes she needs to capture 5 more, which is clearly over 2. So thus her error here is thinking that she needs to capture 5 more instead of 2. So you could say she overestimated by 3 pieces. But the real answer here is 2. She only needed to take 2 more pieces in order to reach the same number. Let's try question 2. Jake bought 16 pencils. Matthew gave Jake some more for his birthday. So that sum means we don't know what it is, and this goes back to that topic of algebra. Now Jake has 39, so this is what he ends up with. I'll call that the final. Write an equation that best represents this, or describes this. So this is going back to algebra again. Jake starts with 16. Matthew gave, implying addition, gave Jake some more meaning x. So this means we're adding on to that original amount a number that we don't know. And then, after putting all that together, you end up with 39, or Jake ended up with 39 pencils. So this is the equation that best describes this. Notice how this question does not ask you to solve for x, but just wants you to write that equation that represents this scenario.